Okay, so this is a video to explain some of the technical details about how Heat3D works. Heat3D is our system for measuring U values of walls and floors using an infrared camera and an app running on a phone or an iPad. The difficulty with using infrared for quantitative measurements is that it doesn't have very good absolute accuracy. So its accuracy for measuring temperatures for any camera will be of the order of plus or minus 2 degrees. So the magic in Heat3D is in these two targets. In particular, this left-hand target, which looks like it's got a QR code on the front. This is actually called an April tag, and it allows the app, the camera in the phone running the app, to automatically identify the exact location of this target. And what we're trying to do with this target is measure the air temperature. So to do that, we have a thin bit of plastic on the face, designed to be very lightweight, and it's very well ventilated around it, and it's insulated from the wall behind it, which will be cold. So it's insulated both with foam and with reflective foil, so it's insulated from radiative heat transfer as well as convection. So we now have this very lightweight bit of plastic that's really well ventilated, so it's really close to the temperature of the air. That's part one. Part two is we've got a Bluetooth temperature sensor in the middle of this target, which is intimately connected to the face of the target. So it's the same temperature as the face of the target, which is the same temperature as the air. And now we can communicate the temperature with the accuracy of this Bluetooth temperature sensor, which is plus or minus 0.2 of a degree, rather than plus or minus 2 of a degree, back to the app, and we can calibrate the thermal image to get accurate quantitative measurements of temperatures. So we can tell the app this pixel here is 20 degrees plus or minus 0.2 of a degree, and that calibrates the whole thermal image. So now we have an accurate measurement of the air temperature. We can compare that to an accurate measurement of the surface temperature, and the temperature difference between the air and the surface allows us to calculate how much convective heat transfer there is into this surface. The other part is this other target, this shiny target. This is called the reflective target. And what we're trying to do with this is measure the amount of radiative heat transfer into the wall. And what it is, a bit of aluminium, which is reflective to infrared. So it's like a mirror, but it's got lots of rough surfaces like this. So instead of being a direct reflection, it's a diffuse reflection of the whole scene. And that allows us to measure how warm or cold all the surfaces in this room are, which determines how much radiative heat transfer there is into the wall. So the temperature difference between the reflective target and the wall surface allows us to calculate the radiative heat transfer. We add that to the convective heat transfer, and now we've got an accurate measurement of the total rate of heat transfer into the wall or the floor. So it's a little summary of what's going on behind the scenes with the Heat3D kit.